Hey guys, this next video I'm going to break into two videos because I don't want to feel rushed and try to squeeze it all in 15 minutes. And maybe I can do it in 15 minutes. I don't know. I just don't want to be rushed because there's so much going on in what we're doing today. Each of these examples are different, and I want you to absorb each example. So please don't speed to the end and do that sort of a thing. This is a really important lesson, and I don't want you to miss what we're doing. So, up until this point, we've been solving quadratics, and we got to where we could find the solutions. But what if the only thing we have are the solutions? Could we create a quadratic equation with just the solutions? I mean, if you told me that the answer to a multiplication problem is 12, do you know what times what is 12? I mean, there's lots of different options for that. There's lots of different factors that when you multiply them together, you get 12. With quadratics, we can take these solutions and we can figure out what the original problem was, what the original quadratic equation is. And then, if we want to graph it or whatever. So let's look at what we got here. First off, remember the solutions, these solutions that we found yesterday, they're also called the roots. You want to remember that word. It pops up. I don't want you to forget it. It's just the x-intercepts. And then we also call them the zeros because they cross over the x-intercept and y is 0. So here we have, it says, again, let's just remember this equation. We're going to try to get to that equation right there with just some solutions. So let's see. It says that these are the roots or the solutions or the x-intercepts, whatever you want to call them. And so first we're going to identify them. There they are. That's step number 1. And then it says that we're going to set both of them equal to x. So we already know that the roots are the x's. So we have x equals -3, x equals 4. So I set them to x. Now, when we finished find the solutions, we ended up with answers like x equals -3, x equals 4. So what we're going to do is we're going to do the inverse. We're going to work backwards. We're going to kind of undo this. So if you remember, right before we got to the step x equals -3 or x equals 4, x equals whatever it is that x equaled, whatever the solution was, we had it set to 0. So we're going to set this to 0 because if y is 0, then x is the solution. Remember that? So to set this to 0, we're just going to move it over. And remember, when we move it over, we do the opposite. Again, some students try to rush through this and they forget that they have to do the opposite. So they'll just put, like for this one, they might just say x minus 3, x plus 4. And it's not. It's the opposite of that. So x minus 4 equals 0. Okay, we have our factors. Whoop, whoop. So now we're going to multiply them together. And I'm going to show you a new method. Some have told me, don't show them this method, but I grew up with this method and it's pretty awesome. First off, I'm going to show you the original method. And by the way, this is one of the reasons I'm cheating and doing 2 little videos instead of 1. The original method, if you remember correctly, was we made these little boxes, which you can totally do. I mean, if this is working for you, and it probably is, go for it. So we have x squared, 3x, minus 3x, 9. Whoops. I thought something was wrong with this. I looked at my key and I'm like, what? This is x minus 4. My bad. You were probably waiting to catch me on that mistake. Okay, So this is negative 4x, and this is plus 12. Okay, so then I'm going to write this out. I get x squared minus x plus 12. And that's doable. That's awesome. And so we can work with that. Now, there's another method, and I think, let me look at some of our examples. I think I'm going to wait. I will wait till we get to example number 3 to show you this cool method that I grew up with and is still used today. All right, look at the next one. Now I have to look. I'm looking at the solutions. So if you look here, we have x equals negative 2 and x equals 1. Okay. First thing, remember, we got to set it to 0. We're working backwards now, so we're going to move the 2 and the 1 over, which means I have to do the inverse operation. Okay, so I'm going to set that. Okay, so they're both set to 0, which of course that means these are the factors. So I have x plus 2 and x minus 1. I can do my little matrix here. X plus 2, x minus 1, x squared, 2x minus x minus 2. So we have x squared plus x minus 2. Bam, we're there. Are you having fun yet? Okay, the next one, we're going to work it out, but when we get to, instead of using the box method, I'm going to show you another method. It's called FOIL. All right, so let's see what this one says. Write the equation in standard form for the graph that has one solution. Now, if you remember, when you had one solution, it really meant that there were two factors with the same number. So I'm going to go ahead and move this over. I have x minus 4 equals 0. I'm going to repeat the process. X minus 4 equals 0. So here are my factors. Okay, cool method I'm going to show you. It's called FOIL. I'm going to write it F-O-I-L. This is an acronym for first, outside, inside, last. And I have been told, don't show them FOIL. Don't show it to them. I don't know why. I mean, when I went to school, like, give me a trick. Help me. I am not a mathematician. I am not uber duper smart. Give me what you can give me to help me get through this to where I don't have to work as hard. So here we go. First, outside, inside, last. What does that mean? I'm going to look at these two binomials, and I'm going to multiply the first term in each one, which would be the x and the x. So x times x is x squared. Okay, outside, I'm going to multiply the first term on the first binomial and the last term on the last binomial. So that would be x times negative 4 is negative 4x. Inside, I'm going to multiply this second term, this right here, this negative 4, and this right here, the positive, with the two that are on the inside, I'm going to multiply them together, and I get negative 4x. And last means I'm going to multiply this term here, the last one, and the last one here. Negative 4 times negative 4 is a positive 16. X, now I'm going to combine like terms. So we have negative 8x in the middle, positive 16. I don't know, try it. It's actually pretty cool. You can ask me about it too in class if you want to say, hey, can you show that to me again? Yes. It's awesome. Okay, whoops. I'm not going to go any further from this. This is part 1, page 1. We'll get to page 2 in just a second. See you in just a second. Bye-bye.